MS Ramaiah University of Applied Sciences.
Hi students, let us have a discussion on verification of KVL and KCL for DC circuits. The objectives of this laboratory experiment are to verify KCL and KVL for the given electrical circuit. The analysis of electrical circuit involves the determination of the voltage across and the current through the circuit elements. This analysis is based on a set of two basic laws, namely Kirchhoff's first law, that is current law, and Kirchhoff's second law, that is voltage law. In general, Kirchhoff's current law is abbreviated as KCL and Kirchhoff's voltage law is abbreviated as KVL. KCL states that the algebraic sum of the currents meeting at a node is equal to 0, or the sum of incoming nodes is equal to the sum of outgoing nodes. KVL states that in any closed path or mesh, the algebraic sum of all the voltages is 0, or in any closed path or mesh, the sum of applied EMFs is equal to the sum of the voltage drops across the elements. While conducting this experiment, the following precautions should be taken. Connections should be made tight and properly. Voltage control knob of regulated power supply should be kept at minimum position. Current control knob of regulated power supply should be kept at maximum position. Now, compare the theoretical and practical voltages across and currents through each elements in the circuit and also comment on your results. This experiment is used in analysis of all electrical networks to find out the voltage across different circuit element using mesh analysis and current through different circuit elements using nodal analysis.
Hi students, let us have a discussion on verification of KVL and KCL for DC circuits. Before going to do this experiment, so let us have some discussion and brief introduction about KCL and KVL. So we know that in general there are the two basic laws to deal with the electrical engineering analysis of electrical circuits. So they are named as Kirchhoff first law and Kirchhoff second law. So in general the Kirchhoff first law, it is also called as Kirchhoff current law, and Kirchhoff second law, it is also called as Kirchhoff voltage law. And in general the Kirchhoff current law is abbreviated as KCL and Kirchhoff voltage law is abbreviated as KVL. And the statement of Kirchhoff current law is, so we know that in any electrical circuits the sum of incoming currents is equal to sum of outgoing currents, or it can also be stated as the algebraic sum of all the currents entering at a node is equal to the 0. And the statement of KVL is the sum of applied EMFs is equal to the sum of voltage drop across the individual elements, or it can also be stated as the algebraic sum of all the applied EMFs is equal to 0. Now, to conduct this experiment we require breadboard to build the given circuit. Next, RPS, this is called as regulated power supply to give the supply, and next multimeter to measure the current or voltage, and this is the probes to connect the multimeter, and these are the resistors to build the given circuit. Before starting this experiment, let us know about the components of verification of KVL and KCL. This is the breadboard. This is used to build the given circuit. So it mainly consists of the 4 sections. Usually they are named as A section, B section, C section and D sections. And top and bottom, that is A and D sections, are used for the grounding purpose, and middle 2 sections are used to build the given circuit. Next we will discuss about regulated power supply. This is called as dual regulated power supply Why it is called as dual regulated power supply means it consists of the two channels. So this is one channel and this is second channel, and this is used to supply the voltage according to the given circuit. This is the multimeter. Why it is called as multimeter means, so by using this meter you can measure current or voltage or resistor or capacitance value. These are the probes to connect the multimeter. These are the connecting wires to build the given circuit and to give the supply. Now measure the value of the resistors based on their color codes using multimeter according to the given circuit. According to the given circuit, the R1 is given that 1 kilo ohm and R2 is given that 2.2 kilo ohms and R3 is 1.5 kilo ohms and R4 is 4.7 kilo ohms, and finally the R5 it is given that 680 ohms, that is nothing but 0.68 kilo ohms, and the required supply voltage is 10 volts. And these are the given resistors. So first R1 is 1 kilo ohm and R2 is 2.2 kilo ohms, R3 is 1.5 kilo ohms and R4 is 4.7 kilo ohms, and R5 it is given that 680 ohms, that is nothing but 0.68 kilo ohms. And these are the 5 resistors to build the given circuit. And first you measure the resistor values using multimeter. Let us take one resistor and you connect multimeter probes across these resistors. Now it is showing 0.98 kilo ohms, so that is approximately is equal to 1 kilo ohm. So this is nothing but R1. Similarly, measure other resistor values, and let us take one more resistor and connect multimeter probes across the resistor. Now it is showing 2.15 kilo ohms, so that is approximately 2.2 kilo ohms. This is nothing but R2. Similarly, one more resistor. Now it is showing 1.46 kilo ohms, so this is nothing but 1.5 kilo ohms, so it is R3. And next resistor, it is showing 4.59 kilo ohms, so it is equivalent to 4.7 kilo ohms. This is R4 according to the given circuit. Next, the final resistor is showing 0.66 kilo ohms, so that is approximately equal to 680 ohms. So this is R5, and make sure that keep the multimeter knob in the resistor position to measure the resistor values. Let us connect the given circuit on the breadboard. Let us take R1 and fix it on the breadboard. Now R1 is fixed. Next, let us take R2, and according to the given circuit, the one end of R1 is connected to R2, so that connecting in the vertical section. And this is R1, and this is middle one resistor is the R2. Now you take R3, and according to the given circuit, the R3 is interlinked with R1 and R2. Now take R4, that is 4.7 kilo ohms. Now according to the given circuit, the one end of R3 is linked with the R4. Now take R5, that is 680 ohms, and R5 it is linked with one end of R2 and one end of R4. If you observe this circuit, so according to the given circuit, the R2 and R4 are interlinked, but on the breadboard these two are separate. Now connect the jumper to interlink R2 and R4 resistors. Now the given circuit is built on the breadboard in the given RPS. Now first let us take one channel and connect the connecting wires to give the supply. And here red one is indicates a positive polarity and black one it indicates the negative polarity. Now according to the given circuit, the positive is connected to the R1 and negative end that is connected to the R5. Switch on the supply. Switch on the supply. Before switch on the power supply, make sure that the voltage should be in the minimum position and current knob should be in the maximum position. Now apply 10 volts by increasing the voltage knob, and according to the given circuit the voltage is given that 10 volts. And here these points are adjusted by fine. Now 10 volts is applied according to the given circuit. Now measure the current flowing through the individual resistors using multimeter. Now take the multimeter and connect the probes. And this black terminal should be in the common position. Next, this red probe should be in the milliampere position to measure the current. So here we are going to measure the DC current, so that this knob should be in the DC current mode. Now to measure the current through the resistor R1, take out one end of the resistor of R1 and connect anywhere else in the circuit. Now R1 is disconnected from the circuit. Now you connect ammeter probes through R1 and R2. Now we can observe the I1 value. It is showing 3.05 milliamperes. Now disconnect one end of R2 to measure the current flowing through the R2 and connect it anywhere else in the circuit, and make sure that it should not be linked with any other resistors. Now connect multimeter probes to measure the current flowing through the R2. Now you can observe the value of I2, that is nothing but current flowing through R2. It is showing that 2.25 milliamperes. Now connect the circuit as it is. Now to measure the current flowing through the R3, disconnect the one end of R3 from the circuit and connect anywhere else in the circuit. Now connect the multimeter probes to measure the value of I3. Now it is showing that 0.79 milliamperes. 0.79 milliamperes. And from this you can observe that the current I1 it is showing that 3.05 milliamperes, and I2 it is showing that 2.25 milliamperes, and I3 it is showing that 0.79 milliamperes. So according to the given circuit, the I1 is equal to I2 plus I3, so that you can verify the current relationship. That is nothing but 3.05 milliamperes is equal to sum of 2.25 milliamperes plus 0.79 milliamperes. Hence the currents are verified according to the given circuit. So from the given circuit it can be seen that I1 is equal to sum of I2 plus I3. So according to the given values, the I1 it is showing that 3.05 milliamperes, and I2 value it is showing that 2.25 milliamperes, and I3 is 0.79 milliamperes. So according to the statement of Kirchhoff current law, the sum of incoming currents is equal to sum of outgoing currents. That is nothing but I1 is equal to I2 plus I3. Hence KCL is verified. Let us verify Kirchhoff voltage law, that is KVL. Now to measure the voltage, so connect these probes in the voltage mode and make sure that this black terminal should be in the common position and this red probe should be in the voltage position, and make sure that this multimeter knob should be in the DC voltage position. Now to measure the voltage across the R1, connect these two probes one across the R1. Now it is showing that 2.99 volts. The voltage across the R1, that is approximately is equal to the 3 volts. So it is oscillating between 2.99 and 3. So it is approximately is equal to the 3 ohms. Similarly, the voltage across R2 is 4.84 volts. And similar way, the voltage across R5 is 2.02 volts. So now voltage across R1, R2 and R3 are measured using the multimeter. So according to the Kirchhoff voltage law statement, so the sum of applied EMFs is equal to the sum of voltage drop across the individual resistors. As per the given circuit, V1 is equal to, as per the given circuit, the voltage, the applied voltage V is equal to V1 plus V2 plus V5. So that means that 10 volts is equal to the voltage drop across the resistance R1, it is obtained at 3 volts, and voltage drop across the R2 it is showing that 4.85 volts, and the voltage drop across the R3 is 2.02 volts. So that 10 volts is equal to the sum of the voltage drop across the resistors R1 plus R2 plus R3. Hence the KVL is verified.
At MSR UAS, we spark your imagination unlike any other.